So picture a day one technician. They're standing right under the belly of a commercial 737, wrench in hand, and they're about to disconnect a hydraulic line.
Right.
Now, they know the steps. I mean, they've read the manual cover to cover. But what they don't know, what that PDF manual hasn't given them the intuition to realize, is that this specific component is holding lethal stored pressure.
Even when the engines are totally shut down.
Exactly. A veteran mechanic, they'd know to listen for a specific hiss, or maybe they'd just check a secondary bleed valve out of pure habit. But our day one tech, they're just following a straight line of instructions.
And in aviation, following instructions without really understanding the underlying physics, well, that's how multi-million-dollar assets get damaged.
Yeah.
Or worse, how people get seriously hurt.
Yeah, absolutely.
Being wrong in that environment isn't just an inconvenience you can patch later with the software update. It is an immediate airworthiness and safety escalation.
Right. And if you are listening to this right now, you, like us, are probably trying to constantly separate the signal from the noise out there. You want to understand not just what shiny new tech is dropping, but how it's actually mechanically rewiring the critical infrastructure around us.
The real deep context.
Exactly, without all the fluff. So let's establish the mission for today's deep dive. We are looking at a system called EON Universal for Aerospace. It was developed by EON AI Ventures.
Yeah, their recent press release.
Right. And this is a facility-agnostic field intelligence layer. What it's attempting to solve is this terrifying massive crisis in aviation maintenance. And it's not doing it by handing that technician under the 737 a slightly better PDF. It's doing it by teaching machines to actually understand the physical work.
Okay, let's unpack this. What is the specific crisis that's driving this urgency right now?
Well, the industry refers to it as the expertise cliff. And it is basically a demographic time bomb, and it's detonating right now.
Wow. Yeah, honestly. Decades of accumulated, highly specialized judgment are just walking out the hangar doors. The senior licensed engineers, the B1 and B2 technicians who certify the aircraft for flight.
And the A&P mechanics here in the States, right? Airframe and power plant.
Exactly. They are aging out and retiring en masse. This raises an important question, though, about how an industry manages when the experts vanish.
But wait, demographic shifts happen everywhere, right? I mean, we see it in software engineering, we see it in finance. Why is aviation so uniquely vulnerable to this cliff?
Because it's different. In software, a senior developer can leave a trail of documentation or, code comments, architectural diagrams. But in aviation line maintenance, the mastery is incredibly tactile.
It's physical.
Highly physical and situational. It's tribal knowledge. It's literally the ability to diagnose a fault based on, the vibration of a floorboard during a test run.
Oh, wow. Yeah, you definitely can't just drop that into a SQL database.
No, you really can't. So as these 30-year veterans leave, they're being replaced by green technicians who are fresh out of school. The ratio of master to apprentice has completely inverted.
So we have an incredibly urgent situation then. The wisdom is evaporating, and airlines need to get these brand new mechanics up to speed in a fraction of the traditional time. I have to assume airlines have already thrown just vast amounts of capital at this problem.
Oh, absolutely. I mean, the historical reflex of the industry has been to pour hundreds of millions into bespoke courseware.
Right.
The prevailing logic was always to build a highly specific, hand-modeled training simulator for every single aircraft type.
So if you buy a fleet of Airbus A320s, you commission an A320 digital training package.
Precisely. But here is the massive flaw.
Let me guess. The moment the manufacturer issues a service bulletin, or the airline changes a seating configuration, or upgrades a landing gear strut, that multi-million-dollar simulator is instantly obsolete.
Instantly. It's just a snapshot in time. The economics of bespoke courseware never close. It treats aircraft maintenance as this endless list of airplane types that every mechanic and every software program just has to enumerate and memorize.
A bottomless pit of recurring capital expenditure.
Because the target is always moving.
It's like trying to learn a new language by memorizing every single full sentence you might ever need to speak in your entire life. You would never finish.
You'd never even get close.
Right. The moment you need to ask a question you didn't memorize, you're just speechless. The alternative, the actual way humans learn language, is to learn the vocabulary, understand the grammar, and then build any sentence you need on the fly.
And that analogy cuts straight to the core insight of EON Universal. They completely recognize that the old approach, memorizing the whole airframe, is fundamentally broken.
So what's their fix?
Their breakthrough rests on one distinct philosophy: composition, not enumeration.
Okay, let me challenge the scale of that for a second, though. An aircraft isn't just a sentence, it's a flying monolith. We're talking about millions of individual parts on a modern wide-body jet.
Right.
You can't just teach someone how a tire works and expect them to suddenly intuit all the complexities of a retracting landing gear system, can you?
Well, that's kind of the illusion of aircraft complexity. It looks like a monolith, but it is actually an assembly of highly standardized industrial components. Across every type of plane, maintenance is largely performed on a finite, bounded library of parts.
A bounded library? Like what?
We're talking about fundamental mechanisms: hydraulic pumps, linear actuators, pneumatic valves, electrical generators, and line-replaceable units, LRUs.
Ah, I see. So instead of learning the whole Airbus,
Oh.
EON Universal learns the underlying vocabulary of those mechanisms. It's kind of like an open source code library.
Exactly like that.
In software, if someone writes a brilliant function for sorting data, the whole global network can use it. So EON is building a shared library of physical components. And once it knows them, it can compose any system on any specific tail number.
And the numbers backing this up in the press release are genuinely startling. When you break down that bounded library, they organize it into 3 tiers of knowledge.
Okay, let's hear them.
Tier 1 consists of roughly 50 component classes. That is it.
Wait, 50? Just 50 component classes make up the bulk of the work. That feels almost impossible for a machine that flies at 30,000 feet.
It sounds wild, but it makes sense when you look at the physics. 50 categories, like a specific class of axial piston pump or butterfly valve, and those 50 classes cover over 80% of the line maintenance tasks a technician performs daily.
80%. Wow.
Because the thermodynamics of compressing air or the fluid dynamics of pumping hydraulic oil, they don't change just because the logo on the vertical stabilizer changes.
Right. An actuator does the exact same job on a Boeing as it does on an Embraer.
Exactly. Then Tier 2 expands to about 300 types, which covers all the specific subvariants. And Tier 3 gets into the really microscopic weeds.
Like what, screws and bolts?
Yeah, 1,000 to 2,000 maintainable items. Seals, bearings, bushings, fasteners.
So by teaching the AI system these 3 tiers, you're essentially giving it the grammar to comprehend almost any machine on the tarmac.
Yes. And to fully grasp the business magnitude of this, we need to contextualize it within enterprise software architecture.
Okay.
Consider how a global corporation operates today. They use an ERP system to track financial and physical resources. They use a CRM to manage customer relationships.
And a PLM for the product's design lifecycle.
Right. EON Universal is establishing a completely new category. They call it the System of Record for Work Intelligence.
Work intelligence, yeah.
It is an enterprise layer designed to capture, hold, and deploy the knowledge of how physical work is actually executed in the field.
Let's ground this in the mechanics of the technology for a second, though. If this work intelligence system relies entirely on this bounded library of components, how does a machine actually know a part?
What do you mean?
Well, if I pull out my phone right now and take a picture of a hydraulic pump, the machine learning model in my camera roll might tag it as engine or metal object. It recognizes the geometry, sure, but it possesses zero understanding of what that object is actually capable of doing.
And recognition is merely the first step. It falls way short of true understanding. To bridge that gap, EON and Universal uses what they call a 6-layer competence record.
6 layers. Okay.
This is how it truly understands a class of components. And crucially, they map this directly to the aviation standard known as ATA ISPEC 2200.
Oh, which is the native data language of the aviation industry, meaning airlines don't have to spend years manually translating their existing maintenance manuals into some proprietary AI format.
Precisely. It digests the data in the format the airline already uses, so it integrates without friction. So let's explore how these 6 layers escalate from basic recognition to actual cognitive understanding. Layer 1 is identity. This is the ATA chapter, the specific part number, and even the colloquial aliases that mechanics use on the floor.
Okay, got it.
Layer 2 is geometry. This involves ingesting a highly detailed 3D model combined with multi-angle real-world imagery.
Okay, so layers 1 and 2 basically accomplish what my phone camera does. It says, I see this shape, its geometry matches this part number.
Right, but here is how it transitions into behavioral physics. Layer 3 is anatomy. The AI understands the subcomponents inside the metal casing and the physical boundaries of the asset in space.
It knows what's inside the box.
Exactly. Layer 4 is function. It ingests the engineering parameters, what the part actually does, and its safe operating envelope.
Interesting.
Layer 5 is behavior. This is where it gets highly dynamic. It learns how this specific component responds to upsets, failures, or abnormal thermal conditions.
And the final layer.
Layer 6 is procedure. How a human is actually supposed to operate, inspect, isolate, and fix it.
That leap from geometry to behavior is fascinating to me. It's taking a 3D point cloud of a physical object and actively linking it to an internal physics database.
Yes.
So it's not just seeing a metal cylinder, it is recognizing a cylinder that is rated for 3,000 psi of pressure and knows exactly how it will react if a seal fails.
What's fascinating here is how the source material draws a strict, unforgiving line between two different software engines to highlight this exact leap. They talk about Genesis and EON Universal.
Right, Genesis being the older legacy core engine they developed, and Universal being this new intelligence layer sitting on top of it.
Yeah, think of Genesis as the on-ramp. Genesis is exceptional at showing the steps. It runs sequential standard operating procedures.
Step 1, Step 2, Step 3.
Exactly. But it requires humans to supply it with the 3D models. It knows what to show the worker on a screen, but it has absolutely no idea why it's showing them.
And Universal is the brain.
EON Universal is the brain. It brings that bounded component library. It doesn't just run static procedures, it authors conditional procedures that actually branch based on live environmental variables.
Oh.
Universal can explain to the green mechanic why a step is critical.
Okay, here's where it gets really interesting. Because to understand the value of conditional procedures, we kind of have to follow our green technician out of the classroom and into the actual workflow. The source material highlights a specific real-world application for this, the hydraulic accumulator test.
Yes, this perfectly illustrates the difference between Genesis and Universal. Let's trace that narrative.
Let's do it.
So, our day one technician is assigned to remove a hydraulic component. Under the old Genesis system, or just with a traditional paper manual, they follow a fixed SOP. It's a straight line, isolate the system, verify zero pressure, remove the part.
But the real world is messy. A fixed SOP assumes ideal conditions, and a hanger is rarely ideal.
Exactly. With EON Universal, because it possesses those 6 layers of competence, specifically layer 5, behavior, the SOP, transforms from a straight line into a dynamic decision tree.
So what happens?
The technician isolates the system and verifies zero pressure on the main gauge. But then EON Universal interrupts and prompts them with a critical question. Is stored pressure still present?
And Genesis couldn't ask that because a legacy system has no conceptual framework for stored energy. It just sees a 3D shape.
Precisely. EON Universal asks because it knows this specific component acts as an accumulator. It's essentially a coiled spring in fluid form designed to hold lethal pressure even when the aircraft is completely dead.
So if the tech answers, yes, there is stored pressure.
The AI branches the procedure instantly. It guides them through a specialized sequence to safely bleed the accumulators down and then prompts a recheck.
And if they answer no?
It just proceeds straight to the normal removal steps.
That is a staggering safety net. I mean, you are taking the hard-won kind of gotcha experience of a mechanic who has actually seen a pressurized line blow. You digitize it, and you inject it directly into the workflow of someone who graduated literally last week.
And the safety net extends even further through an automated escalation protocol.
How does that work?
The moment the AI's sensors detect something abnormal, say a pressure reading outside the envelope, or a geometry it just doesn't recognize from its bounded library, it halts the job immediately and escalates to a human supervisor.
Wow.
The foundational rule of the system, as stated in the release, is the worker is green, but the guidance is not.
The worker is green, the guidance is not. That is so sharp. And the physical ways they deliver this guidance really emphasize how much this tech has matured. We aren't just talking about, reading a tablet anymore.
Not at all.
The sources outline 4 distinct modalities, and you can almost view them as a chronological journey for the trainee.
Let's follow that technician through those modalities then.
Okay, so it starts before they even touch a tool. During initial training, they use talking components.
Right.
The AI gives a voice to the component itself, allowing the trainee to interrogate a virtual part about its function and anatomy.
Which is wild.
Then they move to the anywhere modality. Using a standard smartphone or AR glasses, the tech can project a 1-to-1 scale, high-fidelity model of an engine right into their living room. They can practice complex teardowns totally off base.
And the logistical advantage of that just cannot be overstated. You are completely removing the bottleneck of needing access to a physical multi-million-dollar jet or a scheduled simulator slot just to get your reps in.
But then Monday morning arrives,
Hmm.
and they are in the hangar. This is the in-the-hangar modality. They put on AR glasses equipped with LiDAR depth sensors.
Right.
As they look at the physical aircraft, the LiDAR maps the geometry, matches it to the bounded library, and overlays a digital twin directly onto the real metal.
The actual aircraft becomes a digitally interactive interface.
It's incredible.
And for the absolute apex of training, they deploy the immersive modality, which they refer to as the CVE or the holodeck.
Yeah, that sounds like pure science fiction.
I know, but it's highly practical engineering. Imagine stepping into a room where the walls and floor are entirely composed of high-resolution LED panels, rendering a full-scale maintenance bay completely around you. You are completely immersed.
Oh, man.
And because Universal understands the physics of the machinery, it can actively inject live simulated faults.
Like what?
It can simulate a sudden hydraulic fluid leak or a rapid pressure drop, forcing the trainee to diagnose, react, and isolate the issue in real time under high stress.
Rather than just clicking through a multiple-choice quiz on a desktop.
Exactly.
I mean, if this methodology, learning the vocabulary of parts to intuitively understand the whole, if it's this effective for commercial aviation, its applications have to extend outward, right?
Oh, absolutely. If we connect this to the bigger picture, the industrial implications are massive. This bounded vocabulary approach is completely industry agnostic.
So any heavy, asset-intensive industry built from a finite library of mechanical parts can adopt this intelligence layer.
Any of them.
So we're talking maritime shipping, rail networks, manufacturing.
Yep. The primary target, and the first library already in active build according to the sources, is the oil and gas sector.
Oh, that makes sense.
They are utilizing ISO 14224, which is the international standard for reliability and maintenance data in the petroleum industry.
Oh, okay.
Think about the environment on an offshore oil rig. It is highly volatile, mechanically complex, and honestly, it suffers from an even more acute expertise cliff than aviation because of the harsh working conditions.
Yeah, it's hard to recruit for that.
Exactly. So after oil and gas, they are scaling into mining and broader power generation. The philosophy remains identical, though. Learn the physics of the parts once, and you hold the intelligence to maintain every industrial asset built from them across the globe.
I want to pull two quotes from the EON AI Ventures executive team here to really crystallize the business case, because they strike at the heart of the current artificial intelligence narrative.
Oh, for it.
Dan Lajerskar, the founder, points out that general-purpose AI, the large language models that are dominating the headlines right now, they are incredible at learning the public internet. But they categorically cannot learn how a specific airline's fleet actually runs.
Because the data required to run an airline just doesn't live on the open web. That tribal knowledge, the nuanced operational quirks of a specific fleet of 737s operating in, say, high-salt coastal environments versus dry desert air,
Right.
that knowledge never leaves the physical maintenance sites.
And Lajerskar argues that EON Universal's true value is capturing that localized, site-specific operational knowledge and turning it into an owned enterprise asset.
An asset that doesn't retire.
Exactly. It compounds. Every time a procedure is executed, every time an anomaly is flagged, the work intelligence system gets sharper.
And Mats Johansson, the president, he distills the product differentiation into one incredibly potent statement. He says, Genesis shows the steps. EON Universal understands the work. That single sentence is the product.
The moment the system understands that a specific steel cylinder holds enough pressure to cause a catastrophic injury, the software stops being a digital manual and becomes an active participant in human judgment.
It really is the systemic digitization of wisdom.
So what does this all mean? Let's recap the journey of this deep dive. We started with a demographic time bomb, right? The expertise cliff. Decades of specialized tactile judgment retiring, replaced by a wave of green technicians in an industry with zero margin for error.
And we analyzed why the legacy approach of endlessly building bespoke, static training simulators is basically a financial dead end.
Right. And we explored how shifting the paradigm to composition, not enumeration, turning the entirety of aircraft maintenance into a bounded vocabulary of just 50 core component classes, it completely changes the mathematical reality of training.
By utilizing a 6-layer competence record, bridging the gap from simple 3D geometry to complex behavioral physics, this intelligence layer doesn't just recognize machinery, it truly understands it.
It dynamically authors conditional procedures, it anticipates the invisible dangers of stored energy, and it actively stops a green technician before they make a fatal error. whether they're scanning a real engine with AR glasses in the hangar or battling simulated fluid leaks in a KV environment.
It is a remarkable blueprint for applying highly targeted, domain-specific AI to solve a tangible physical world crisis. But as we close out this analysis, I want to leave you with a final thought to mull over.
Lay it on us.
We are crossing the threshold into an era where the hard-won judgment of a 30-year veteran mechanic can be digitized, packaged, and seamlessly handed to an employee on their very first day.
Yeah.
The immediate safety benefits and the efficiency gains are undeniable. But if an AI perfectly guides a green technician through complex life-or-death maintenance by understanding the grammar of the machinery for them, what happens to the inherent compounding value of human intuition?
That's a great point.
Will the next generation of technicians become so deeply reliant on the AI's understanding that they lose the ability to troubleshoot organically when the systems fail or the screens go dark?
Wow.
Or, conversely, will this exact digital safety net free their cognitive load from the rote memorization of manuals, allowing them to push the boundaries of mechanical engineering even further than the veterans who came before them?
Will the tool become a crutch that atrophies human instinct, or will it become wings that elevate it? That is a phenomenal question.
Yeah.
And it's exactly where we will leave it for today. We've gone from the tactile, messy realities of a hangar floor to the pristine digital layers of AI cognition and back again. Thank you for joining us on this deep dive. Keep questioning, keep learning, and we'll catch you next time.